All right, in this video, we're going to discuss an important term in chemical thermodynamics called spontaneity. Now, spontaneity looks like the word spontaneous, and you would be correct if you made that assumption. You've all heard the term spontaneous. I spent a lot of time on dating apps before I got married, and this is before Tinder and anything else that succeeds Tinder. And one of the things that you see on people's profile is that I'm looking for somebody that's spontaneous. And spontaneous essentially means I'm looking for somebody that can suggest that we go do something without actually planning ahead of time. Right? Somebody that doesn't make plans. Let's just do it. Yeah, it sounds fun. Right? And, that's great in your 20s. But when you finally start getting responsibilities and stuff like that, it's hard to be spontaneous. But chemical reactions don't care about whether you're single or you're busy. When we say spontaneous in thermodynamics, we mean something completely different. When we talk about spontaneous, we're talking about a process that occurs without any work being inputted to the process, okay? So let's talk about examples of spontaneous processes. And a lot of these are oh, okay, that does make sense. First thing is if I take some ice out of the freezer and place it on a countertop at room temperature. Right? Once you take the ice out of the freezer and you put it on the countertop, it melts. Did you do anything to it? Nope. You did nothing to it. Okay, so that's an example of a spontaneous process. If you take some sugar and you throw it in some coffee, right? Remember, coffee is pretty much water-based here. The sugar dissolves without you doing anything to it. Okay, so that's another example of a spontaneous process. Okay. If you have a tank of gas, like helium, that's under tremendous pressure, and you open up the valve, well, what happens? Right? The pressure, the gas moves from an area of high pressure to low pressure. That's an example of a spontaneous process. Okay. Some of you have maybe outdoor furniture. Most of you have a car. Some of you have playground equipment as a kid, and if any of that stuff is not made of stainless steel or galvanized, over time, right, the metal is going to rust. Okay, so the rusting of iron in presence of oxygen and water. Okay, if there's no oxygen, you can't oxidize iron. If there's no water, you don't have a medium in which to carry out the process of rusting. And this is why a lot of airplane graveyards are found in Arizona, because it's so dry out there that the airplanes don't rust. And so people will turn around and sell to airplane enthusiasts a very old airplane, and it can be easily restored because there's no rust on it. And you find a lot of car graveyards out there too. It's one of the things that's kind of neat to go visit if you ever go out to the desert Southwest. Another thing, and this one might not be as obvious, is the combustion of natural gas, methane. And you're probably sitting there thinking, wait a minute. In order to get methane to combust, I have to add heat. No. No. Methane combustion happens extraordinarily slowly. Okay, but it does happen. If you fill up a room with oxygen and methane, right, it will convert to carbon dioxide water at a rate so slow that it's almost undetectable. Okay. So what I want you to understand here is that spontaneity is not dependent on rate. Some processes are very slow and some processes are very fast. In either way, if you don't input any work, it's a spontaneous process. Now, one thing you should notice too here is that do any of these processes happen in reverse? The answer is no, not spontaneously, right? So what we're going to talk about in this chapter is another and very, very important and also very abstract thermodynamic value called entropy. And when you factor in enthalpy, essentially heat, and entropy, this is going to help us determine whether a process, whether it's a chemical reaction or a mechanical process, can be spontaneous.